Hello and welcome to the video. In this video I'm going to be solving a question from paper 3 of IBDPHL analysis and approaches. Now paper 3 is a 55 mark paper and you're given 1 hour and 15 minutes to solve this paper. It mostly has 2 questions and both the questions are pretty lengthy. You need to be mindful, patient and very calm when solving paper 3, because every sentence in this question matters. You will have the knowledge, but if you are not being calm and composed at that moment, you may not be able to solve the question. What is important is that you practice a lot of questions of this type, like you practice paper 3 questions, right? That would help you to solve paper 3 during the examination itself. Let's look at this question. Now this question is famously known as desert jeep problems. If you Google, you will find a lot of questions on a jeep and the desert and different scenarios and cans of petrol or unit of petrol or something like that. This is one such question. So I will be uploading this question in the description so that you can look at it. And I'm not going to solve the entire question in this video. In this video, I'm going to try and explain to you what is happening in the question. And probably in the next video, I'll try and break it down to 3 parts and then explain each part to you. So what is he saying here? He's saying that there are a group of explorers who wish to travel deep into the desert. And what they have is 3 units of fuel. They just have 3 units of fuel, and each unit of fuel can travel for 200 kilometers. Okay, each unit of fuel can travel for 200 kilometers. And what he's also mentioning is that the distance is distributed uniformly, which basically means that in 1/4 of the fuel I can travel 50 kilometers. That's what he says. Now with that information given, they start off their journey. What is their goal? That they travel as far into the desert as possible. They want to go into the desert as much as possible, okay, with just 3 units of fuel, right? And they have to plan for it. So what they first do is to leave their base with 1 unit of fuel, because the jeep can carry only 1 unit of fuel, all right? And they travel to P1, which is the first point. They come back, but when they come back, they leave some fuel at P1 and then they come back. And you can read through this. Every statement here is important, all right? So let me explain what actually is happening. Let's say this is the point where they start from, right? And this is like an open desert. This entire thing is a desert. Right, so they have 3 units of fuel. Let's say they start from here and go to a point, let's say P1, okay, and then they also go to P2, and then they go to, let's say, a point P3. Now nowhere in the question is he saying that the distance between P1 and P2 and P3 are all the same. He's not mentioning that, you see. All right. Now, what he is doing is this. He travels from the base. Goes to P1, leaves some amount of fuel over here, keeping only enough fuel to come back to the base. Then picks up 1 more can of fuel, travels to P2, leaves some fuel over here and carries only enough fuel to come back to P1. From P1 he fills in some amount of fuel that will give him an opportunity to return back to the base, and from the base he takes 1 more unit of fuel, travels to P3, remains with enough fuel to come back to P2, fills in petrol at P2, gets enough fuel to come back to P1, and then fills in the remaining petrol or fuel at P1, returns back to base. Now that itself would have been a bit of a task for you to understand, right? But I would want you to re-look at the question, re-look at what I have said, okay? And then come back to the further explanation. If you have understood it, good. So what I know is that 1 unit of fuel takes me to 200 kilometers, which simply means that to travel 1 kilometer, I need 1 by 200 of your fuel. 1 by 200 unit of fuel. And what does that tell me? That tells me if I had to travel X kilometers, then I will need X by 200 units of fuel. Okay, great. Let's say this distance is X and this distance is Y and this distance is Z. So if this is X, the amount of fuel required to travel this distance is simply X by 200. Okay, and same thing goes here, X by 200, X by 200, Y by 200 here, Y by 200 here, and then finally I have a Z by 200. Okay, great. So what does he do first? He travels from the base, goes to P1, leaves some amount of fuel. Let's say he leaves A by 200 amount of fuel and then comes back to the base. Now when he's traveling back to base, he carries only X by 200 amount of fuel, which is enough for him to come back to base. The same thing he does here. He leaves some amount of fuel here. Let's say he leaves B by 200 amount of fuel, and then he carries enough fuel to just come back to base. Okay. And in the third expedition with 1 unit of fuel, he's not leaving any fuel back, so he's just traveling the distance back. So this is the situation, right? Now I'm going to make use of this and make some equations. Can I say that this unit of fuel plus this unit of fuel plus this unit of fuel, and then returning back to the point P2, which is this unit of fuel, they all will add up to 1 unit of fuel? Yes. So can I make an equation saying X by 200 plus Y by 200 plus 2Z by 200 as equal to 1, and that gives me the first equation, which is X plus Y plus Z, 2Z as equal to 200. That's going to be my first equation. Now let's look at the second one, or let's come back to the first situation here. Can I say X by 200 plus X by 200 plus the amount of fuel left at P1, all this will account to 1 unit of fuel. And further, can I simply say 2x plus A as equal to 200? Remember, I'm making certain equations here. So this is going to be my first equation, and that's my second equation. I can also say that the fuel left and this fuel used, they all will again sum up to 1. So that's X by 200 plus 2Y by 200 plus B by 200 as equal to 1, and that gives me another set of equation, which is X plus 2Y plus B as equal to 200. X plus 2Y plus B as equal to 200. Okay, great. Now let's get this. In the third expedition, it goes here from the base to P1, then goes to P2. I'm going to erase this, and then goes to P3, returns back to P2. And from here, he takes all the fuel that is left, which is B by 200, to travel this distance. And that fuel is enough for him to travel that distance, which basically means that B by 200 is equal to Y by 200. That's the amount of fuel that was required. And if I go with that, I can blindly say that Y is equal to B. Y is equal to B. Now, what does that do to me? Well, I'll have the equations. Y is equal to B, so I can write this as x plus 3y is equal to 200, and then I have the equation that as equal to 200. Now this is 1, 2, 3, 4 variable, 3 equation, not solvable, which means I need one more equation. So now what we're going to do is to look at what happens when he comes back from P2. When he comes back from P2, he's refueling at this particular point, and that's going to give him enough fuel to go back to the base, which means he's going to be taking x by 200 amount of fuel from P1 and then traveling back to the base. Now this fuel that is left, he's using this fuel when he's returning back from P3. So when he comes back from P3, he gets some fuel from point 2, goes to point 1, that gives him enough fuel to go back to point 1, and from point 1 he gets enough fuel to go back to the base. So how much fuel does he require to go back to base? X by 200. And therefore, can I simply say that the amount of fuel that is left at P1 is equal to the amount of fuel required to go back to the base. And therefore, from here, I can simply say that A is equal to 2x. What does that do? Well, if A is equal to 2x, this equation will now become 2x plus 2x is equal to 200. That tells me that 4x is equal to 200, and the value for x is a 50. Value for x is a 50. So if value for x is a 50, then I can write this as 50 plus 3y is equal to 200. That tells me that 3y is equal to 150. That again tells me that y is also a 50. And if y is a 50, then I can substitute that in this equation. I can say 50 plus 2z is equal to 200. You can see that 2z is going to give me 100. That means the value of z is also 50. What is that telling me? It tells me that all these points are equidistant. And what is the distance between them? 50. Alright, all this is of distance 50. See, it has taken time for me to explain the question as to what is happening. In your paper 3, you're supposed to understand, decipher, and solve it within a short period of time. And that is why it's very, very important that you practice such questions and get used to thinking in a very calm and clear mind. All right. In the next video, I'll try to solve question itself, which is part A, part B, and part C. This should actually help you to solve part A, part B, and part C. All right. I hope you understood the question. Again, read through this question multiple times. Get the idea correct. Okay. Thank you very much for your patience. Goodbye.